This video is going to look at the difference between empirical and molecular formulas. So if we have something like fructose, it has the molecular formula of C6H12O6. That is the formula that we've been working with predominantly up until now. So molecular formula tells you a lot about how the molecules are kind of attached in space, meaning you have 6 carbons, 12 hydrogens, and 6 oxygens. It doesn't tell you about the ratio between carbon, hydrogen, and oxygen only. It tells you exactly how many atoms of each type of element are present within the single chemical molecule. Empirical formula, on the other hand, is going to be the smallest ratio of atoms that still relates the ratio of the individual atoms to the whole compound. Meaning, if I were to reduce C6H12O6 to the smallest whole number ratio possible, all of these numbers are divisible by 6. So meaning carbon could reduce to 1, hydrogen to 2, and oxygen to 1 as well, which tells me for every 1 carbon there are 2 hydrogens and 1 oxygen. That is an empirical formula. All right, it's showing you how the ratio of how the atoms are connected within the molecule, but not actually showing you how many total of each there are. Okay, so then you have other molecules like serotonin. Serotonin, on the other hand, is C10H12N2, and remember, if they don't have a 1, it's an understood 1. So in this ratio, this is the molecular formula, but it is also the empirical formula, because even if you divide all of these by any single number, 1 is your only option. That's the lowest common denominator of it, and so if you divide everything by 1, you get the same formula. So in this case, our molecular formula and our empirical formula are the same. Now these ratios are very helpful for us figuring out what is the actual makeup of a molecule. And so we'll look at an example in a minute that lets us relate molecular and empirical formulas to each other, but mainly for the process of we can learn a lot about a molecule based on how many of each type of element are actually present in the molecule.